In problem 14, we're asked to evaluate some expressions. Notice for part A, we're given an expression and a value for the variable. So whenever I see an x in the expression, I want to replace that with the value negative 11. Doing that gives me negative 11 squared minus 5 times negative 11 and plus 1. Notice that I put each of those negative 11s inside parentheses because I want to make sure that the entire operations in this expression get applied to the value negative 11. So negative 11 is being squared, that becomes a positive 121. Negative 5 times negative 11 is positive 55, and then plus 1. Adding those together, I get 177. In the next example, we have two unknowns. We have x and y, but we're given a value for both of those. Y is negative 3, and x, we want to use the value 5 for that. So this time I'm going to replace each x with a 5. So I get 5 cubed plus 4 times 5. And I'm going to replace each y with a negative 3. So negative 3 squared minus negative 3 cubed. Notice that I didn't put parentheses around that initial 5. It wouldn't hurt to put them, but I don't need them. Whereas I do, it gets a little confusing if I don't have parentheses around these other parts of the expression, because I want to make sure the entire negative 3 gets squared, and I want to make sure that I interpret the 4 and 5 as multiplication and not 45. So let's see. 5 cubed is 125, plus I can multiply the 4 and the 5 together to get 20. And then separately, let me square the negative 3. Negative 3 squared becomes a positive 9. And now at the end, I have negative 3 cubed, which equals negative 27. But then that has a minus sign in front, so it becomes a plus 27. So I have 125 plus 20 times 9 is 180 plus 27. And adding up those numbers, I get 332. 125 plus 180 is 305, plus 27 is 332. In my next example, I want to substitute this fraction for each of the x's. Doing so gives me 2 times 1/2 plus 1. And then that whole expression is multiplied with 1/2 minus 4. So from this first part of the expression, I end up with 1 plus 1. So that will just become 2. The second factor in the expression, 1/2 minus 4, is going to become negative 3.5. So what I really have is 2 times negative 3.5, which of course is going to equal negative 7. Two more expressions to go. In our next example, I have 3 variables, a, b, and c. Substituting 2 for a, negative 6 for b, and negative 7 for c, I get negative 6 squared minus 4 times 2 times negative 7. Of course, I'm squaring that entire negative 6. It's going to become a positive 36. And then negative 4 times 2, I get negative 8. Taking that times negative 7 gives me a positive 56. So I have 36 plus 56, which adds up to 92. And finally, our last example might seem a little bit intimidating, but it's actually not too bad. I need to replace each of these x's inside the fractional expression with a fraction, 5 over 3. So when I do that, I get a complex fraction, 5 over 3 divided by 5 over 3 plus 2. So we can simplify this if I rewrite the 2 as 6 over 3 I can see that the denominator, these two fractions, add together to be 11 over 3. And then the last step in our process, I want to multiply both the top and the bottom of the big overall fraction by 3 over 1, by 3. That's going to cancel each of these 3's, and we can see that the value of the expression when x equals 5/3 is simply 5 over 11. So there we have it. We evaluated each of the expressions. We ended up with 177 for part A, 332 for part B, -7 for part C, 92 for part D, and 5 over 11 for part E.